Yeah. Hello, I'm Chris Glencross. I work for Goldman Sachs. Subject of the talk is Eclipse Collections by example. And I'll just do an introduction first. That's me in the top left, a terrible photo. This is Don Rabb, who's the guy who created GS Collections initially. This is Hiroshi Ito, who works in our Tokyo office, and he has been doing a lot of the recent enhancements and giving talks at Java 1, and yeah, his name's associated very closely with GS Collections and Eclipse Collections. This is what I'm roughly going to talk about is a bit of an introduction about what GS Collections is, what we're doing with it to make it become Eclipse Collections, give some information about what the features are, a bit of a flavour of why we created it, what it's good for, how it compares to some of the standard Java features. And then I'll try and get on to some examples of how it gets used. I know I've got far too many examples in here, so I probably won't have time to go through all of them, but I'll do the best I can. If you want me to get to the examples quicker, I can do that. So I'll try and get through the first few things pretty quickly. And hopefully I'll have time for some questions at the end, but we'll see how it goes. So GS Collections is a collections framework similar to Java util collections or some of the other open source products that are available. It implements standard Java util collections APIs, but extends them with extra features. We started creating it internally within the firm about 10 years ago, so it's fairly mature. We open sourced it 2 or 3 years ago, 3 years ago. The code is available on GitHub. You can download it, try it out. There's lots of documentation, training materials on there. There's a GS Collections kata, which is a set of training materials, exercises where you can write some tests. It's basically a set of unit tests that you can run. The tests, when you download them, will fail. You need to go and fix the code to make the test pass, and it's kind of training materials, so you get to learn the API. The reason we open sourced it back in 2012 was really that as a development organization, we're very large. We have something like 10,000 people in our technology division. We consume an awful lot of open source software, and the developers...
10,000 developers?
They're not all developers, but yeah, 10,000 people in our technology division. So some of them are managers and other things. But I heard John say 6,000 developers, which may be correct. Let's say something like that. So we're big, and we're global, and we use an awful lot of open source software, including Eclipse products, but open source software from everywhere. And we wanted to give some stuff back, and it's hopefully also good for our reputation, but we'll see. So some of the feedback, on that note, some of the feedback we've had on GS Collections since we open sourced it and started talking about it at Java 1 last year. You can see the number of downloads from Maven. Some other open source products have started depending on it. So Spring Reactor uses GS Collections internally for some of its performance and memory usage characteristics. We're listed on websites which say what they think are good open source products to be using for high performance Java applications. And you can see on GitHub how, well, basically people are using it, and you can correlate people downloading it and trying it out with news stories that are appearing on blogs. So it's getting a fairly positive reception. So what we're doing with it is it was recently announced we're joining the Eclipse Foundation. We've joined the Eclipse Foundation, and we are transferring the code over to the Eclipse Foundation. And the way we're doing this is we're taking what is going to be the next version of the code, which is GS Collections GS Collections version 7, and we are moving it across to the Eclipse Foundation. The main change is just to the package name. The functionality will be parity, and then from that point on, we'll start developing new features as part of the Eclipse Foundation. One of the reasons for doing this is the Eclipse Collections is going to be open for contributions because of legal, reputational things. Unfortunately, with GS Collections on GitHub, we haven't been able to accept contributions from other people, and most of the development enhancements we've been doing have had to happen behind closed doors, and then we publish the next version to GitHub, which isn't really the way that we want to work. but moving the code over to Eclipse will allow us to develop it in a more open fashion. So why would you want to use it? Especially since you've got Java 8 streams. So Java 8 added a lot of new functionality to the Collections API, where you can use a Fluent API for manipulating data in collections. And it adds a lot of functionality, and it's quite nice to use. So why would we want anything else? Well, Eclipse Collections lets you use because it implements all the standard Java collections interfaces, you can carry on using all that stuff. We're not trying to replace it, but we give you more choice. We have, as well as lazy APIs, which Java 8 streams are, we have, you can do the same kinds of functionality with eager APIs. Let's give some examples of that later. We have memory-efficient containers. So actually, the reason that GS Collections was first created was because we had some very large in-memory caches with tens or maybe 100 gigabytes of heap, and we were seeing garbage collection times that were unreasonable. Bearing in mind this was back in 2004, where hardware was slower, you could see garbage collections taking minutes or more. So performance tuning these applications, it basically became clear that the overhead of some of the standard Java collections was causing us problems. So we started off by creating our own implementations of some of those collections using the standard APIs. On the same vein as having efficient containers for objects, we created primitive containers, so int array list, int map, maps of ints to objects, maps of objects to longs, that kind of thing, which means that you don't need to box all the primitive objects that you store in the collections. And then in terms of just adding functionality to the API, we've got immutable containers, so unlike unmodifiable wrappers around your collections, we actually have interfaces which are unmodifiable versions of the collections, so you can have an immutable collection by contract being returned from your API. We have more container types, more iteration patterns, and we're Java 5 we're currently at least Java 5 compatible.
So does this mean if I want to use Java 8?
You can use Java 8 and you can use streams with Java 8.
And this still works? And
it still works, but if you're using the Java 8 streams functionality, you can't then use it on Java 5. If you see what I mean? Yeah. And then you can use all the Java 8 streams API as well. We're not trying to replace it, so you can pick what you want to use. I mentioned memory usage. And this, as I said, this is one of the reasons that GS Collections was created in the first place. If you compare the JDK hash set usage with just storing very small, lots and lots of very small objects in it, you can see that for 1 million objects, the JDK hash set was using 50 meg, whereas the GS Collections hash set for storing very small objects is using less than 10 meg for an equivalent. And I can talk a bit about how that works if you're interested. Yes? Okay. It's when you store something in a hash set, a Java hash set, first of all, it's just a wrapper for a hash map, which means that you have slots for keys and values when you don't really need that. The other thing is that every time you store an object, it creates a wrapper object, which is a map entry. And we avoid doing that as well. The way it works is by having a single array containing all your buckets, both keys and values, and the keys and values get written into alternate slots. So evens are your key and odds are your values. It relies on the fact that you're not getting many collisions in your hash map. If you start getting collisions, then it will replace the value with a list of values. But in the majority of cases, you won't have collisions, so we can get low memory usage. You don't need those wrapper objects. Similar with maps, although slightly less pronounced because we need to store keys and values. We have primitive collections as well, as I mentioned. So the top orange line there is the JDK array list containing boxed integers. And then, obviously, the int array list, where you're storing ints in an array, saves a lot of memory because you don't have to box all the values. Hobson's choice. Sorry, yes?
That was in terms of the memory performance. Do you talk about runtime performance as
I don't have graphs on that. I'll mention some things, but yeah, not specifically. Were there any questions you had on that?
Well, I was wondering whether getting rid of all the boxing and unboxing would have a...
Oh, yes, it does. Yeah. So the fact that you don't need to box and unbox, well, particularly box the integers and create objects on the heap and stress the garbage collector can make a big difference depending on what you're doing. Yeah.
Have you been having talks to like contribute part of it, which makes sense to OpenJDK?
So yes, actually, Don Rab, whose photo was in there, was actually, or I think he still is, or was on the JCP group for the Streams API, and he has been talking to Brian Gertz about this for a long time, long time, and some of the Stream API design came. Don was in discussions with the team coming up with that. So I don't think there's any plan to actually take GS collections or Eclipse collections as it is and import it wholesale. Probably taking some of the best ideas and including them. I might have I did definitely gloss over a bullet point earlier, which was about when the code comes across to Eclipse collections, it's actually going to be slightly odd for an Eclipse product. It's going to be dual licensed. So it'll have the Eclipse public license, and it'll also have a BSD license, which we wanted to do because it allows other projects that want to use it but don't want the Eclipse license, including OpenJDK. It would allow them to take pieces of the code which they wouldn't be happy doing if it was purely Eclipse licensed. So we are thinking about this, yeah. So Hobson's choice is a choice where there's only really one option. And the analogy here is that streams work really well, but we're providing more options. So for example, with the Streams API, everything's lazy. So you create a stream and you start mapping and filtering things on it. It won't at any point create you an intermediate collection containing all the values. It will read items from the initial stream and read them through the pipeline of operations on your stream, which is good for many cases and works most of the time. There are times when you might want to do something different. So with Eclipse collections, you get the choice. You can, on a collection, you can say as lazy, and it gives you a view of the collection where the iteration operations over that collection are actually lazy, and it streams the data through, similar to Java 8 streams. So you get the choice, and it's very easy to switch between the two. You get more choice of collections. So Eclipse Collections has bags. I mean, this is all stuff that you can do with Java, but it requires more boilerplate code with the standard collections. So bags are roughly, they're like sets, but you can store duplicate objects in them. And to implement that in the JDK collections, you'd probably have a map of key to integer, where the integer would be the count of the objects of that type in the collection. We have multimaps as an explicit type, which is like a map of lists of objects. A bimap, which is a bidirectional map, so you can go from key to value and also do efficient lookups from value to key as well. With Java, you'd probably implement two maps and you'd store the object twice. We have partitions. A partition is really a result from a partitioning operation. So if you have a collection of objects and you want to scan them and decide, do they find the ones that do match the criteria and the ones that don't match the criteria, you can return a partition which contains the ones that match and the ones that didn't match in two separate collections. With Java, you'd probably do that as a map of Boolean, true, false, and then a list of the items in each. And we have a pair type as well, which people often use a map.entry to try and simulate if you're passing two objects or receiving two objects from a collection. When your only tool is a map, you end up implementing everything as a map, basically. Some other options, we've talked about, I'm going to try and move on to the code examples quickly. We have primitive collections of everything. Unlike Java 8 has primitive streams, but for integers, longs, and doubles only. We have all 8 types, so you can have a stream of characters, for example. I'm moving on quickly. Any questions on this? Tell me if I'm going too fast. I just want to get to the code examples. And another place where we provide more options. Does anyone use parallel streams with JDK streams? So you want to perform a set of operations on a stream of data using multiple worker threads. Java 8 has a very nice API for this, where you can say you can get a parallel stream and then you can perform operations on that stream, and Java takes care of managing a pool of threads and batching the data to each of those threads so that you don't end up with too much overhead for the threading compared to the amount of data you're working with. We have similar functionality, but we give you more options. You can provide your own thread pool, and you can be explicit in providing your own batch size. So how many elements do you want to give to each thread in one go? So you can try and tune the performance more than the Java defaults let you. And in fact, the Java defaults are really designed for working with CPU-intensive tasks. So the size of the thread pool it uses is based on the number of cores on your machine, because it assumes that all the work you're doing is CPU-intensive. If your tasks are actually doing something else, like calling out to a database, and you're going to be blocking, you may want to throw more threads at it. It's not easy to do that with the Java 8 streams. I'm on to the examples. How am I doing for time? Okay. Any questions on that background as to kind of the high-level overview of what Eclipse Collections are going to provide? Or actually, I'll mention timelines, because I didn't mention it already. We're going through the process now of moving the code to Eclipse Collections, to the Eclipse Foundation. It's had some legal reviews earlier this week, which got passed. We are now about to start transferring the code to the Eclipse Git implementation, after which it'll go through a review for intellectual property stuff. And we're hoping to actually have the code available packaged on Eclipse Christmas-ish. Fingers crossed.
Do you plan to join the simultaneous release?
Not at the moment, is my understanding. Until there start being dependencies between the products, it's probably unnecessary. We'll see what happens. I don't know the official answer.
Well, I would like to use it, but it's actually awkward if you're not in the release.
It's a separate product. It'll be available for. Sorry, can you explain the question? So,
in the simultaneous release,
yes.
it might be awkward if it depends on something that isn't.
Yep. Yep. So at the moment, we don't have any of those dependencies. Nothing in the Eclipse, nothing else in Eclipse is depending on this at the moment. And Eclipse Collections has no dependencies on any other libraries at runtime. So we don't have that issue yet. When it happens, we might join the simultaneous release. We'll see. I don't know. I don't know. Is probably the truthful answer. But not straight away. So the examples. So we're going to be working with this simple domain model where a person has a pet or a number of pets, and a pet can be has a type field. The person has basically a list of pets, a bag of pets even, and also has a method which is person.hasPet with a pet type, which returns a true or false. This is our first bit of code that we've seen, which is doing a pets.anySatisfy this predicate, which probably looks kind of familiar to people who've used Java 8 streams. There's no .stream operator, and that anySatisfy is eager, so it won't be streaming the data. The sample code is implemented as a JUnit test, and this is the setup where we're setting up some test data, which is a mutable list, which extends the Java util list, or implements Java util list, where we're creating a mutable list with a person who has a number of pets. I'm not going to list. Yeah, setting up a set of test data, people with their pets, in a list of people. So, first bit of sample code really. Do any people have cats? This is how you do it with Java 8 streams. People familiar with this? Yep. It's people.stream. So to get you have that stream operator is probably the main difference to what I'm about to show you, and the name of the method. People.anySatisfy predicate is really very, very similar. It's eager, which means that this code really just, anySatisfy just iterates over the items in the list and returns true if any of them match that predicate. You can imagine what the implementation of that anySatisfy would look like. It's pretty simple. But here's something a bit different. We have an anySatisfy with method. And what's different here is that we're passing a second parameter, which may not seem like a big deal because they're fairly equivalent. Where it can make a difference, well, some people prefer this style. Person.hasspec use method references. Some people like method references a lot. Where it can make a difference is if that second parameter was a local variable in the enclosing scope, the first code would end up creating a Lambda object that captures that outer variable and would pass that into as the predicate, whereas the second one doesn't create any temporary garbage. So if you care about performance and you don't want to stress the garbage collector, the second approach can be slightly more efficient. You probably wouldn't notice it much of the time unless you're really micro performance tuning. And then same thing again, but with a lazy implementation. Where the laziness really makes a difference is if you have it doesn't make a lot of difference here, but if you have a long pipeline of operations, so you had a stream of data and you wanted to map it to something else and then filter it. With the eager approach, first of all the data would get mapped into a second collection, and then that data would get filtered. So temporarily, you'd have two copies of the data or two collections in memory at once. Whereas the lazy approach means that items in the stream get processed one at a time, and you don't end up with two copies of the data. This is very similar again. How many people have cats? We instead call the count method at the end instead of the we call count with and count instead of anySatisfy. Let's mention the naming convention. It might have been nice if the method names here matched the Java 8 streams method, anyMatch, anySatisfy. GS collections predate streams, so there's not much we can do about that. But the naming convention here comes from Smalltalk. A lot of the API design was inspired by Smalltalk.
Couldn't you just add new methods with new names?
Yeah, you could do.
Like delegate to the existing ones?
Possibly, yeah.
Yeah.
We could do. This isn't a code slide. This is another situation where you might want to consider eager versus lazy. I gave an advantage of laziness as you don't end up with multiple copies of the collections. An advantage with eagerness is that the stack trace that you end up with is very much smaller than compared to both Java 8 streams and GS collection lazy iteration. And that is important if you care about performance and inlining. We've written micro benchmarks, and typically this block of code would get compiled by hotspot into a single block of code that can be inlined because it's not particularly deep call stack. The other example, I seem to remember that 11 or 12 is the maximum call stack that hotspot will inline by default. So you can end up with big performance improvements when you're not streaming. But then there are other disadvantages as well. So it gives you the options. Who has cats? The top example you may be familiar with, we are using collect here. So with Java 8 streams, when you want to collect data into a data structure, so you're working through the stream, you want to write the results into another collection at the end that you can then work with, you provide a collector to the collect method, which describes what you want to do with that resultant set of streams. We have select with, so we don't have collectors in the same manner, or select and select with, and they actually return a collection. So for the majority case where you, probably, I think, for the majority case where you're reading data into another data structure of the same type that you're reading from, you can get less code, a bit. Just assign it straight to a list, and the API is slightly more fluent because you don't need to then go off and look at the collectors API to see what kind of collectors are available in the library. And again, lazy is just the same with as lazy. Who doesn't have cats? Slightly more descriptive API, we have reject with, whereas in Java 8, you've got to filter with a not. You've got to insert a not into your predicate. It's a small thing. Partitioning. I mentioned earlier that one of the collection types that we have is a partition. And this is an example of where you can use it. So in Java 8, you would have you would use a partitioning collector where the key of the thing that you're inserting into the map is a Boolean to say whether or not the person matches. And you would end up with two lists of people, one of which is stored in the map as a Boolean true, and the others with the key false. Here we actually have an explicit data type in Eclipse Collections, which is a partitioned list where there are actually two methods on it, one of which is getSelected, which is returns you the objects that matched the partitioning criteria, and a getRejected, which gives you the objects that didn't match the partitioning criteria. So the API is a bit more explicit, with explicit types to support that use case. Getting the name of Bob's pets. So here we are in the streaming version. First of all, we're getting a person. We're looking for the person that matches, is named Bob Smith. We find the first, which gives us an optional, and we call get to unpack the optional, which would throw a runtime error if there wasn't one. And then to get Bob's pets, we get his pets, stream those, get the names, and then there's a Java util collectors, stream collectors joining method, which is a collector that concatenates strings with a delimiter. The Eclipse Collections equivalent, more readable maybe. Detect with finds one person or one object in a collection that matches the criteria. We've got detect and detect with, which takes the extra parameter. And then the collection returned has an explicit method on it. It's a slightly more fluent API which is a make string, which does what you expect. It makes a string with a delimiter. Getting the set of all pet types. This is the flat map example. So we're streaming all the people, and then for each person, we're streaming the types of the pet, the types of the pets that person has, and then we're writing all those pet types into a single set to get a distinct set of all the types, which is what the first stream example is doing. We have a flat collect, and this is the first time. Actually, I'll talk about why not do this. This is an example of eager collection. The toSet call at the end will actually copy the set. It will copy the. This returns a list, mutable list, I think. The toSet will actually take another copy of it, so it's a bit wasteful on memory. So what you want to do instead is actually provide, and this is available for all the GS collections, Eclipse Collections methods, so you can provide a target collection into which it should write the data to avoid having to copy the resultant flat collected type to a set. With streams, you don't have that issue, because it's writing the values to a set as it goes along, streaming data, so you don't end up with two copies in memory. Grouping people by their last name. Yeah. So I'm trying to remember which example this was. After you look at these slides for a while, they all start looking the same. It's true. Grouping by streams. So we're using a grouping collector which writes the values into a map, grouping by the lambda that you provide or method reference that you provide. So it's grouping by last name, which is what you want. Here we're actually showing some interoperability with Eclipse Collections. So the Java 8 collectors can provide, like some of the Eclipse Collections methods that we saw, you can actually provide a target into which to insert the data. So that's what we're doing here, but we're actually demonstrating that interoperability works quite well, that we can actually create an Eclipse Collections bag, an empty bag, and use that as the target to create the values in the map. We have an explicit group by with no need for stream and collectors. So if you're doing this just with Eclipse Collections, the syntax is slightly more concise. I'm running out of time, I know. I'm going to move on. This is getting the age. It's much the same as we had before. Again, this is showing interoperability, showing that the int summary statistics, which is something that comes with Java 8 for getting maximum, minimum, mean, sum, I don't know if it's got standard deviation in there or not. You can actually insert all the data into this thing that aggregates integer values as it goes along, and we can interoperate quite nicely with Java 8 functionality for that. I'm going to move on. There's another example which is pretty similar. One key difference I wanted to point out is we've talked about lazy, shown plenty of examples of Eclipse Collections lazy iterable structures. One fundamental difference to Java 8 streams is that streams behave a lot like an iterator in Java, that you create one, you read objects from it, and when you get to the end, you're at the end, and you can't really use that anymore. Whereas the Eclipse Collections lazy object, when you call that lazy as lazy method, what you actually get back is a lazy iterable, which behaves much more like a lazy collection than it does an iterator. So you can actually use it for doing stuff and then reuse it. So you can call lazy iterable.collect minimum, and that actually will internally create an iterator type structure in that method. And then when you call collect int again, it'll create another iterator over that collection. So that can be more convenient, but it is just something to be aware of at least, that these aren't like streams.
So what happens if you have a list and you make s lazy and
Mm-hmm.
perform an operation and you add something to list and then you do another iteration, another operation with lazy iterable. So you create a lazy iterable for
Yeah.
the list?
Yes, I get the question. So if you're modifying it, so the lazy iterable is, I think, a view onto the data. So if you modify the underlying data, then you iterate over it again, you'll see the extra data. I think that if you have race conditions and you're adding things while you're iterating over it, it's probably implementation dependent as to what that collection was. But if you're doing just adding things and then iterating again, it'll do what you hope it would do. Very last slide, almost. Almost. So just the convention. We provide views onto existing collections. So we talk about as lazy as providing an adapter, which is a view onto an existing collection, changing the behavior so that iteration is lazy. We also have as unmodifiable, which provides you a read-only API for accessing that data. Synchronized, parallel, reversed. So if you're iterating it as reversed, it'll iterate backwards over that data. We have two methods as well, but these take a copy of the data. So it's really just the naming convention. As creates you a view, to creates you a copy of the data in a different data structure. And then finally we have some convenience function. There's actually quite a few different convenience functions that the framework provides. Here's an example of procedures.throwing. So if you have a method reference that throws a checked exception, and you want to use that somewhere that is expecting a functional type that doesn't throw a checked exception, you can create an adapter using procedures.throwing, which catches all checked exceptions and rethrows them as runtime errors, so that you can conveniently use that object in an iterator, in an iteration pattern. This is too small to read, too much information. These slides are available on the conference website, so you can go and have a look. I'm being told to stop right now. That's it, which is perfect timing. You can give feedback.
Question. Any comparison with the Google collections?
With the
Google
collections. I'm not an expert on the Google collections. This question has come up a lot. The main difference is that the Google collections didn't re-implement any of the standard Java collections, so there's no hash set, no hash map. They just rely on using the standard Java ones, and they augment those with extra collection types, which means that you don't get the memory efficient implementations. I don't think they have the primitive collections, but I might be wrong on that.
They have, but I'm not sure if it's collections on an Android they have.
Okay.
And the second question would be, this works also on Android?
Yes, it does. What I have, actually, I'll qualify that. I think it does. It has no dependencies on anything else. I have had feedback that because the primitive collections are all code generated and they're very large APIs, the footprint of the jar may not be ideal for mobile devices because it has very large numbers of methods and very large numbers of classes. That I haven't worked with it on Android, so I don't know. Yes?
Any reasons to not prefer these collections over the standard Java collections? I mean, you said you didn't have any time measurements on performance, but I assume that in terms of what we learned about the primitive types, it's definitely going to be faster.
Yep.
What about the other collections, just the fastest?
I can't think of any examples. I think, John, you might know the answer better to this. I've heard that map.entrySet is maybe less performant because map.entrySet relies on the internal representation of the hash map using map.entry objects, which we don't, which means that we actually need to create those objects as you're iterating over the entry set. So there might be some small cases, but in general, no, we often use them instead of the standard Java ones. That's probably it. Yeah. But I'll be around a few minutes afterwards.
What's the full memory footprint of the jar? How big is the jar?
You've got me. A couple of meg, 3. I can check. You download it and have a look. I don't know.
It's like because you said it's rather big for
yeah.
rather big, right?
Yeah, I don't know. I honestly don't know.